Hi! Once again, this is Marinil Gomez, and today we will be discussing about the most recent structural model of the atom, the wave mechanical model. The wave mechanical model is based heavily on the field of quantum mechanics. You know, that one field where the laws of reality seem to bend, that which pop culture uses as an excuse to hand-wave scientific incongruities. But what exactly is this field? To have an idea, let us consider the nature of light. Light, as we all know, is an electromagnetic radiation possessing properties of a wave. White light, such as those emitted by the sun, is made up of radiation of different wavelengths. These wavelengths are the ones that we see on the rainbow. If you remember, the colors in a rainbow blends together, red turning to orange, which in turn becomes yellow, and so on. This continuity is what you call a continuous spectrum. Now remember the hydrogen spectra I mentioned last time? Hydrogen gas, when energized, emits light as well. However, instead of emitting light of a continuous spectrum like that of the rainbow, it emits light only of a specific set of colors or wavelengths. And since the energy of light is proportional to its wavelength, we can therefore say that energy emitted by an energized hydrogen gas is only of very specific values. You might be wondering, what's the connection of this with atomic structure? You see, when you energize hydrogen, it is the electron of the hydrogen atom that absorbs energy and becomes excited. An electron in an excited state jumps from a lower energy level to a higher energy level. Imagine a person from the first floor of a building going up to the second floor. Now, the electron cannot always be in an excited state. It will eventually release that energy and go to its ground state. When the electron goes back to its ground state, it goes from a higher energy level to the lower energy level it originally came from, like the person going back to the first floor from the second floor. When this happens, the energy release is always of a discrete quantity, as seen by the very specific wavelengths of light in the hydrogen spectra. This means that the energy levels of the electrons jumps to and fro are of discrete whole number quantities. We can better understand this by imagining the electron as a ball and the energy levels as steps on a staircase. The ball, when it moves from one step to the next, travels a discrete horizontal distance from its starting point. The ball can never occupy half a step, and in a similar manner, the electron cannot be in between two energy levels. Now we have established that electrons occupy positions of certain energy levels, and that these electrons jump to higher energy levels when excited. We are now going to have a closer look at the positions the electrons occupy. Electrons occupy regions of increasing distance around the nucleus. These regions are termed as shells or energy levels. The shells closer to the nucleus have lower energy levels than those further away. Each shell is further on divided into subshells or sublevels. There can be one or more subshells in each energy level. You can imagine the positions electrons occupy as condo units in an urban residential area. Each shell or energy level can be compared to a building. Each building is made up of floors, hence the shells also have subshells or sublevels. Each floor is made up of units or rooms. For the atom, these subdivisions of the subshell are called orbitals. Not all buildings have the same number of floors, and not all floors have the same number of rooms. Likewise, shells have different numbers of subshells, and subshells have different orbitals. We shall be discussing more on these subshells in the next video. The positions electrons occupy follows the three basic principles: Aufbau principle, Hund's rule of multiplicity, and Pauli's exclusion principle. The first one, Aufbau, is a German word meaning build up. It means that levels of lower energies are filled up first before those with higher energies. Let us consider the first electron of an atom. it will occupy the lowest energy level. Within this level, there is only one subshell. And in that sublevel, there is only a single orbital. So obviously, the electron will go there. Since each orbital can accommodate 2 electrons, the second electron will also go in that orbital. Since both electrons occupy the same orbital, won't they become identical? Of course not. Electrons spin, and for electrons occupying the same orbital, they are spinning in directions opposite each other. This is Pauli's exclusion principle. Now, for the third electron. Since the first energy level is already full, it will now go to the second energy level. The second energy level has 2 sublevels. The electron will first occupy the sublevel with the lower energy. This lower energy sublevel has a single orbital, which the third electron will occupy together with the fourth electron. For the fifth electron, it will then have to occupy the sublevel with the higher energy. This sublevel has 3 orbitals of equal energies. This sixth electron will also go to the sublevel, but will occupy the other orbital and won't share the orbital with the fifth. The same goes for the seventh. Only when the orbitals of equal energies have been singly occupied can the next electron pair up. This is Hans' rule of multiplicity. And so this continues on until all the electrons of the atoms have their positions assigned to them. That's it for now. We will be discussing more on these shells and orbitals in the next video. Please answer the assessment questions and see you next time!